Welcome to this new video. So in this video we are going to study about the design of superelevation, how the design of superelevation is done for mixed traffic conditions when slow moving vehicles as well as fast moving vehicles are present on the road. So let's have a look. Since mixed traffic operates on Indian roads, the superelevation design complexity increases. It is very difficult. It becomes difficult for everybody to design the superelevation just because the traffic moving on the road or the vehicles moving using the road are having mixed speeds. That is, slow moving vehicles are also there and fast moving vehicles are also there. So for that reason, we need to design super elevation for a particular type of vehicle. These are some of the points. The low value of super elevation will cause fast moving vehicles to rely on the lateral friction component, which is very unsafe practice. And high value of super elevation will cause the toppling of slow moving vehicles. So when if we provide super elevation to be very slow, the fast super elevation to be very small, the fast moving vehicles will have to rely on the lateral friction component for prevention of toppling of the vehicle, and that would be very unsafe. And next is high value of super elevation will cause the toppling of slow moving vehicles such as below carts or slow moving traffic such as cycles or other uh, passengers, right? So for that we design the super elevation for 75% of the design speed, and we neglect the lateral friction. So super elevation is calculated for 75% of the design speed and neglected for by neglecting the lateral friction. So we'll take F is equal to 0 and we'll calculate E. For this, D would be equal to 0.75 of design speed of the road, and we'll take F is equal to 0. If we input those values in the equation above, we'll get E is equal to V upon 225 R. From this, we can calculate the super elevation required for the road. Next, uh, these were the some of the values for maximum super elevation that is available for different terrains. If plain and rolling terrain is there, 7% is the maximum super elevation allowed. Mountainous and steep terrain is there is only 10% of the super elevation is allowed. And urban and built up area, it is only 4%, which is equal to the camber for general roads, right? Next, as soon as we calculate E is equal to V upon 225 R, this will give us the value of E, and it should be limited to a maximum of 7%. That is what we have written in the step 2. If calculated value of E is less than 7%, the value is adopted. If the value of super elevation calculated from this formula is less than 7% and greater than 4%, the value is adopted. If it is greater than 10, then the value adopted is 7%, right? If calculated value is more than 7%, E is taken as 7% and checked for lateral friction only. Then we check the lateral friction developed in the vehicles, which should be equal to uh, or less than 0.15. That is the allowable lateral friction for the vehicles on horizontal curve. So in the step 3, check the friction developed for the vehicles that is moving at a design speed and E is equal to 7%. So here we have used the formula for V upon 225R. Here we'll check lateral friction for the vehicle moving at the design speed. Right here we'll not use the 75% value. Here we'll check the lateral friction for a vehicle moving on the design speed with super elevation of 7% because that is what we have fixed here. We'll take E is equal to 0.07 and B is equal to design speed of the road. So we'll calculate F from this formula. If friction developed is less than 0.15, the super elevation is safe. Otherwise, we calculate the allowable speed. If it is not possible for the vehicle to develop friction more than 0.15, it is taken as unsafe and we need to limit the speed of the vehicle. Other way around for that is we can increase the radius of the curve, but in some cases it is not possible to uh, increase the radius of the curve due to acquisition of nearby areas or land acquisition for the nearby areas. For those cases, we calculate the allowable design speed, for which lateral friction will be 0.15 and maximum super elevation would be 7%. That is what we'll calculate in the next step. Here E plus F is equal to V square upon 127R, and we'll take E is equal to 0.07 and F is equal to 0.15, right? V allowable will be calculated in kilometer per hour and R is in meter. All the other values are such that the values are in, this is in meter and this is in kilometer per hour, right? Please remember this, otherwise this sometimes causes problem, and this causes loss of marks, right? If allowable speed is higher than the design speed, then the design is adequate, but if it is less than the design speed, the speed is limited to the allowable speed. On many highways, it is such that the speed is not reduced and the curve should be realigned with larger radius of curve. For that, we need to limit the speed of the vehicle to the design speed, and we'll calculate R from here. For that, E is also fixed as 0.07, F is fixed for 0.15, and B allowable is fixed to B design, and for that we need to calculate the radius, right? Next we'll look at the numerical portion of this. So let me start it once again. We'll start from calculating the super elevation. So for super elevation, we'll calculate E from the formula V square upon 225 R, where V is equal to 80. So 80 square upon 225 multiplied by 210, that would be equal to 80 multiplied by 80 divided by 210. That is coming out to be 0.135, and that is a very high super elevation and that needs to be reduced. So we'll look into that in next part of the question. Super elevation that we have calculated is equal to 0.135. Since it cannot be provided, we'll limit the super elevation to 7%. So we'll take E is equal to 0.07, and radius of curve cannot be redesigned as given in the question. So radius is also fixed to be 210. F is fixed to be 0.15. We need to find the V allowed, or we can say V allowable speed, right? It would be equal to it will be calculated from E plus F is equal to V square upon 127 R. Here we will calculate, so we'll put it on one side. This would be equal to V is equal to E plus F would be 0.15 plus 0.07 is to be multiplied by 127 multiplied by 210. This would be the value of allowable speed, right? So let's see what is the value. 0.15 plus 0.07 is to be multiplied by 127 is to be multiplied by 210 raised to the power 0.5. The allowable speed is coming out to be 76.59 kilometer per hour. So the allowable speed on the road is 76.59 kilometer per hour. So that's all from my side for this video. Next we'll look at the attainment of super elevation in the field. That will look in the next video. So for that, please like, comment your doubts and questions and any suggestions that you want me to give, and please subscribe. Thank you. Have a nice day.